Hello everyone, we have question number 4. ABC is an isosceles triangle, right angle at C. So here what we know is ABC is an isosceles triangle. At the same time, what happened? One of the angles, the angle C is 90 degrees. So this ABC is an isosceles right angle triangle. Okay, now let me draw here. I'll draw one side here and let me draw another side. Okay, and this is 90. I'll take this right angle as C, and here A and here B. Now we have the triangle ABC. This triangle is an isosceles triangle because I have taken here AB and AC are equal. At the same time, angle C is 90 degree. This is the figure that we have. Prove that AB square equal to twice AC square. First I'll write solution here. Okay, then given. What I'm going to write in the given, first I'll write ABC is an isosceles triangle in which AC equal to what? BC, and angle C is 90 degree. I have written the given. Next we are going to write to proof. In to proof, what we are going to write? We are going to prove that AB square equal to twice AC square. Okay, next we need to write proof, or you can write procedure. In procedure, how are we going to start? Okay, we know that this ABC is a right angle triangle because angle C is 90 degree. So I'll write here, from triangle ABC, what we can write? We can write here AB square equal to what? You can write AC square plus BC square because it is a right angle triangle. So you can say from Pythagoras theorem. Okay, so after it, what happened? The question tells you that AC equal to BC. So I'll write here implies AB square equal to here AC square plus. Next we have BC square, but the question gives you that AC is what? BC. That means AC and BC are equal. So in place of BC, let me write AC. Then we have here square, so I need to write here square. Okay, then what happened? AB square equal to what? Here AC square, so we have here twice AC square. This is how we have done the proof. And beside this, let me write, since AC equal to BC, then we have to write this one, and I'll write here hence proof. Here we have question number 5. ABC is an isosceles triangle with AC equal to BC, and again it says that if AB square equal to twice AC square, prove that ABC is a right triangle. Okay, so let me draw here the isosceles triangle ABC. Okay, the question tells you that AC equal to BC. Here I'll take here C, then here is A and here is B. Here what happened? AC equal to what? BC. Okay, and then one more condition is this, AB square equal to twice AC square. Okay, now let's start the solution. Let me write given directly here. Given. In given, what we're going to write? We're going to write here ABC is an isosceles triangle with, what is that? AC equal to BC. And what is the next? We have here AB square equal to what? Twice AC square. Next, we need to write here to proof. To proof. We have to prove that ABC is a right angle triangle. So let me write here ABC is a right angled triangle. Then next we have here proof. Okay, let me start from here. I'll write here AB square equal to twice AC square. This is given by the question, so you can just write here given. Next implies AB square equal to twice AC square means we can write AC square plus AC square, implies AB square equal to, here we have AC square plus AC square. Okay, fine. Here we have seen that, I'll show you something here, AC equal to BC. So in place of this AC square, let me write BC square plus AC square. What we find here is AB square equal to BC square plus AC square. Here what happened? The square of one side is equal to the sum of the two other sides. Here AB square equal to what? BC square plus AC square. That means from the converse of Pythagoras theorem, let me write from the converse of Pythagoras theorem, ABC is a right angle triangle. But here hypotenuse will be definitely AB, therefore its opposite angle, that means angle C, will be 90 degrees. So ABC is a right angle triangle at C. We have question number 7. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. So before we start, we should know about the rhombus. Here let me draw a rhombus. Okay, so let me say A, B, C, D. It is a rhombus. And here let me draw the diagonals. BD is one diagonal and even AC is another diagonal. So one of the basic properties of the rhombus is diagonals bisect each other at right angle. Let me repeat. Diagonals bisect each other at right angles. So here let us think that these two diagonals intersect at O. So what happened now? Diagonals bisect each other. That means AO will be equal to what? CO. AO will be equal to CO. Like that, BO will be equal to what? DO. BO will be equal to what? DO. And this angle AOB, angle BOC, angle COD, and angle AOD, all these angles will be right angle, 90 degree. That means angle AOD, angle AOB. I'll write here angle BOC, angle COD. These all four angles will be how much? 90 degree each. With this, we'll start a solution. So first, let me draw a rhombus. Okay, I'll give here A, B, C, D. And then what happened? BD is one diagonal and AC is other diagonal. And these two diagonals intersect at where? At O. I'll give here like this. This is O. First, let me write the given. A, B, C, D is a rhombus where the diagonals AC and BD intersect at where? At O. That is the given. So what shall we prove? Let me tell you now. I didn't explain before. to prove. Okay, let's see. The question says that the sum of the squares of the sides, the sum of the squares of the sides of a rhombus. Here, what are the sides of the rhombus? AB, BC, CD, AD. Okay, sum of the squares of the sides. That means AB square plus BC square plus CD square plus AD square. This is what we call sum of the squares of the four sides is equal to what? Sum of the squares of its diagonals. I'll write equal to here. Sum of the squares of its diagonals. Here the diagonals are BD and AC. You can write here BD square plus AC square. This is what we have to prove. Next, I'll write procedure. Is the diagonals as the diagonals of a rhombus bisect its other at right angles. What we can say? We can tell here that AO equal to, you can say CO is equal to what? Half of AC. Here I'll give you question number 1. Second, you can write BO equal to what? You can say OD or DO, it's fine. DO equal to what? 1 by 2 of BD. And then I'll give you question number 2. And next, we can write here, and angle AOB is what? 90 degree. So as the angle AOB is 90 degree, we can tell that triangle AOB is right angle triangle. Therefore, AOB is a right angle triangle. As angle AOB is what? 90 degree. As angle AOB is what? 90 degree. So let us apply Pythagoras theorem. Okay, we'll see now. Below this I can write AB square equal to, you can write AO square plus BO square. What do you have to write here? You can write here from Pythagoras theorem. So implies AB square equal to, here AO means what we can write, in place of AO I can write half of AC. So I will write here half of AC, then whole square, plus in place of BO what I can write half of BD. So I'm going to write here 1 by 2 of BD whole square. Okay, so now let's see now. Implies AB square equal to what? 1 by 2 AC whole square. That means you can write 1 by 4 AC whole square like this, plus here also you'll get 1 by 4 of BD square. Then what happened? I can write here implies AB square. So let me take 1 by 4 common now. 1 by 4, then after that AC square plus BD square. Below this what we can write? We can write here implies 4 into AB square. We'll be getting here 4 AB square equal to what? AC square plus BD square. Below this let me write AB square plus AB square plus AB square plus AB square. How many times? 4 times. Equal to what? AC square plus BD square. Okay, now let's see. We know that the length of all the sides of a rhombus are equal. So what happened? I'll write here like this first. In a rhombus, what happened? The length of all the sides are equal. As ABCD is a rhombus. What happened? AB equal to BC equal to CD equal to what? AD. So this is AB. Okay, now what happened? AB square plus, in place of this AB square, now let me write BC square, because AB BC all equal only, plus in place of AB let me write CD square, plus in place of this AB again let me write AD square, then equal to what? Yeah, I have written here AC square plus BD square. Now let me just write here like this, BD square plus AC square, exactly like the two proof. Now we have completed the solution. So let me write here, hence proof. This is what we have to prove.